Good morning everyone, welcome back to the 8th session. In the previous session, I did brief you all about the chapter Determinant, wherein we studied about the definition of determinant, how do we denote the determinant, how do we represent the elements in a determinant, how to calculate the value of 2 cross 2 and the 3 cross 3 determinants, and the signs associated to the determinants. Moving on to the second part, I did prove about 8 properties of determinant, and in the last session we solved few problems based on the determinants. In today's session we shall continue with these problems. Coming forth, find the value of x if determinant of 2, 4, 5, 1 is equal to determinant of 2x, 4, 6x. How do we calculate the value of 2 cross 2 determinant? Product of the principal minus product of the secondary. So 2 1s are 2 minus 5 4s are 20, which is equal to 2x square minus 24. That is product of the principal minus product of the secondary. So moving on to the next step, 2 minus 20 will be minus 18 is equal to 2x square minus 24, implies minus 18 on the RHS, 2x square minus 24 plus 18. So minus 24 plus 18 will sum up to 2x square minus 18 minus 24 minus 6 equal to 0. This is equal to 2x square equal to 6, and what is the value of x? Plus or minus square root 3. This is the value of x is equal to plus or minus square root 3. Moving on to the second problem, we have determinant of 2, 3, 4, 5, which is equal to determinant of x, 5, 3 and 2x. As I told you, product of the principal minus product of the secondary will give you the value of the 2 cross 2 determinant. So that is nothing but 10 minus 12 equal to 5x minus 6x. 10 minus 12 will be minus 2, 5x minus 6x will be minus x, minus minus gets cancels on both the sides. So what is the value of x? X is equal to 2. Moving on to the third part of the problem. Determinant of x to 18x is equal to determinant of 6 to 18, 6. So it is product of the principal minus product of the secondary. This will sum up to x square minus 36, which is equal to 36 minus 36. RHS tends to 0. Minus 36 on the RHS. X square is equal to 36. X is equal to square root of 36. It's a perfect square. X is equal to 6. X is equal to 6. Moving on to the next part of the problems, we shall solve few problems based on properties of determinant. Before we start solving the problems based on properties of determinant, let me quickly summarize all the 8 properties that we have solved in the previous session. The first property, the value of the determinant is unaltered if its rows and columns are interchanged. The next one, the sign of the determinant changes if any 2 rows or any 2 columns are interchanged. The next property, inner determinant, if any 2 rows or any 2 columns are identical, the value of the determinant tends to 0. Next property, inner determinant, if all the elements of any row or any column are 0, then the value of the determinant is equal to 0. The next property, inner determinant, if the elements above the principal diagonal are 0 or above the principal diagonal are 0, then the value of the determinant is equal to product of the principal diagonal element. Next property, inner determinant, if you multiply any row or any column by a constant k, then the value of the determinant is multiplied by a constant k. The next property, the sum of the 2 terms can be expressed as sum of the 2 determinants. And the last property, if you multiply any row or any column by a constant k, and if you add that to the corresponding row or corresponding column, then the value of the determinant is unaltered. So, based on these 8 properties, let us solve few problems. Now, first property, the first using property of determinants, prove the following. The first problem, prove that determinant of x a, x plus a, y b, y plus b, z c, z plus c equal to 0. Now, we have to first look at the RHS. When we look at the RHS, what is RHS? It is 0. We are supposed to prove this determinant is equal to 0. Once again I repeat, we are supposed to prove this, the value of this determinant is equal to 0 by using properties of determinant. When we remember the 8 properties of determinant, which property of determinant states the value of the determinant is equal to 0? Only when 2 rows or 2 columns must be identical, or if all the elements of a row or column must be 0. So, using these 2 properties, we have to solve the problem. The moment we look at the problem, we need to quickly summarize which property satisfies the given problem. So, as I told you, property of determinants, either 2 rows or 2 columns must be identical, or all the elements of a row or column must be identical. Using these 2 properties only, I have to solve the value of the determinant is equal to 0. Why I have to use only these 2 properties? Is by using only these 2 properties, the value of the determinant tends to 0. So, moving on to the first problem, I can add column 1 with column 1 plus column 2. If I am using column 1, I will mention here as column 1. If this is column 1, your immediate operation must also be column 1. If you use column 2 in other problems, your immediate operation should also be column 2. If it is C3, your immediate operation must also be C3, and the process is same with R1, R2 and R3. I am changing only column 1 here. So, which 2 columns remains the same? Column 2 and column 3. So, I will retain column 2 and column 3 as it is. This is column 2, A, B and C, which is column 3, x plus A, y plus B, z plus C. I am adding what? Column 1 plus column 2, that is column 1 plus column 2. So, x, what operation is this? Plus. So, I have to add with column 2. I can write this as x plus A. Similarly, I can write this as y plus b, and the third problem as z plus c. Now, can we notice here 2 columns are identical, that is column 1 and column 3. According to the property of determinant, if any 2 rows or any 2 columns are identical, the value of the determinant tends to 0. So, in this problem, column 1 and column 3 are identical. So, we can say that the value of the determinant is equal to 0. Directly write which is equal to 0, because C1 and C3 are identical. C1 and C3 are identical. Therefore, the value of the determinant tends to 0. Moving on to the next problem. We are supposed to prove the value of the determinant is equal to what? 0. So, when you observe RHS, which 2 properties of determinant satisfies the value of the determinant tends to 0? The first property will be either 2 rows or 2 columns must be identical, or all the elements of a row or column must be 0. So, by using these 2 properties, I have to prove the given determinant is equal to 0. Prove that determinant of A minus B, B minus C, C minus A, B minus C, C minus A minus B, C minus A minus B, B minus C equal to 0. Either I have to make 2 rows or 2 columns identical, or I have to make all the elements of any row or any column 0. Automatically, according to the property of determinant, the value of the determinant tends to 0. So, in this problem, I can add, when you look at the problem, if I have to make, I cannot make it as identical. The only option left out is I have to make all the elements as 0. If I have to make all the elements as 0, I can just add all the columns, or I can add all the rows. So, suppose I add R1 tending to R1 plus R2 plus R3. R1 is changing. If I am changing R1, my immediate operation should also be R1. If I consider R2, my immediate operation will also be R2. If I consider R3, immediate operation should also be R3 and so on. Now, I am changing row 1. My R2 and R3 remains the same. What is R1 plus R2 plus R3? A minus B plus B minus C plus C minus A. This is R1 term, this is R2 term, and this is R3 term. Finished adding R1 plus R2 plus R3. How do you add column? A minus B, C minus A. This becomes the column. How do you add rows? A minus B plus B minus C plus C minus A. Similarly, with the next one, B minus C plus C minus A plus A minus B. B minus C plus C minus A plus A minus B. Moving on to the third row, C minus A plus A minus B plus B minus C. R1. R2 and R3 remains the same. So, what is R2? B minus C, C minus A minus B. R3 also remains the same. What is R3? C minus A minus B, B minus C. When you observe, plus A minus A gets cancels in R1, minus B plus B gets cancels, minus C plus C also gets cancelled. Similarly, plus B, minus C plus C, minus A plus A. When you observe the third term, plus C, minus A plus A, minus B plus B. So, the first element in the first row after cancelling all the terms becomes 0. Similarly, the first term also becomes 0 and the last term tends to 0. What is left out? B minus C, C minus A, C minus A minus B, A minus B, B minus C. Can we observe here all the elements of the first row are 0? Property states that if all the elements of any row or any column are 0, then the value of the determinant tends to 0. So, here we observe that all the elements in the first row is 0. So, directly we can write the value of the determinant is equal to 0. Moving on to the third problem. What is the third problem? States that prove that the value of this determinant should be equal to 0. As I explained you in the last two problems, when it is equal to 0, either two rows or two columns must be identical, or all the elements of any row or any column must be equal to 0. So, in this problem, suppose I add R1 tending to R1 plus R2. What do I get? I am considering R1, my immediate operation will also be R1 followed by the left out terms, either R2 or R3. Now, R1, so what is R1? X plus Y, I am adding with what? R2. What is R2? Plus Z. Similarly, Y plus Z, that is R1, I am adding with R2, which is R2, that is row 2, X. And the last one, Z plus X plus Y. I am considering only R1 operation, so R1 changes, R2 and R3 remains the same. What is R2? Z, X, Y, 1, 1 and 1 again. So, what is common in R1? When you observe this, what is common in R1? X plus Y plus Z is a common term in R1. So, taking X plus Y plus Z, take X plus Y plus Z as common factor in R1. So, when I take out X plus Y plus Z as common factor in R1, what is left out? 1, 1 and 1 again. So, what is the second row remains the same because you are taking this as common factor in R1. Z, X, Y, and the last row also remains the same. So, what do we observe here? We observe here that R1 and R3 are identical. If any two rows or any two columns are identical, the value of the determinant tends to 0. So, in this problem we observe that R1 and R3 are identical, therefore, the value of the determinant is equal to 0, which is equal to 0 because R1 and R3 are identical. R1 and R3 are identical, and hence the value of the determinant is equal to 0. Moving on to the next problem we have. Prove that determinant of 2, 7, 65, 3, 8, 75, 5, 9, 86 equal to 0. Which two properties satisfies the value of the determinant equal to 0? Either 2 rows or 2 columns must be identical, or all the elements of any row or any column must be identical. So here, if I consider C3, my immediate operation is also C3. C3 minus 9C2. So my column 1 remains the same. What is column 1? 2, 3 and 5. Column 2 also remains the same, that is 7, 8, 9. Here I have considered column 3. What is column 3? Column 3 is 65. With what sign do I have here? Minus. 9 times. What is column 2? This is column 2. So 9 times, what is the element present in column 2? 7. Similarly, 75 minus 9 times 8. Again, 86 minus 9 times 9. So what do we get? Determinant of 2, 3, 5 remains as it is. 7, 8, 9. 9 sevens are 63. 65 minus 63 will be 2 again. Similarly, 75. 9 eights are 72. 75 minus 72 will be 3. Similarly, 9 nines are 81. 86 minus 81 will be 5. Can we observe here column 1 and column 3 are identical? If any 2 rows or any 2 columns are identical, automatically the value of the determinant becomes 0. So in this problem, we observe column 1 and column 3 are identical, and therefore the value of the determinant is equal to 0. It is equal to 0 because C1 and C3 are identical. Moving on to the next problem. Prove that determinant of 1 BC AB A into B plus C, 1 CAB into C plus A, 1 AB C into A plus B equal to 0. Once again, we will use only the 2 properties of determinants because RHS must be equal to 0. Here, I will write column 3 tending to column 3 plus column 2. Since I am using column 3 operation, my immediate term is also column 3. Column 1 and column 2 remains the same. So what is column 1? 1, 1 and 1. What is column 2? BC, CA, AB. What is column 3? I have to add column 3 with column 2. What is column 3? AB plus AC is column 3. AB plus AC is column 3. I am supposed to add with which column? Column 2. What is column 2? BC. Similarly, what will be the term here? BC plus BA. This is column 3. The operation is addition. I am supposed to add with which column? Column 2, that is CA. Similarly, CA plus CB plus AB. Can we observe here AB, BC, CA? Similarly, AB plus BC plus CA, and the third term AB plus BC plus CA. So I can take what as common factor from column 3? AB plus BC plus CA as common factor. So take AB plus BC plus CA as column factor in column number 3. So I am speaking about column number 3. So column 1 and column 2 remains the same. So I will retain column 1 and column 2 as it is. Which term is taken as common factor? AB plus BC plus CA. Column 1 remains the same. 1, 1 and 1. Column 2 also remains the same, that is BC, CA and AB. I am supposed to take what as common factor? AB plus BC plus CA in column 3. If I take out AB plus BC plus CA in column 3, what remains here? Taking this as common factor, 1, 1 and 1. The value of the determinant is equal to 0. Why it is equal to 0? Can we observe here column 1 and column 3 are identical? If these two columns are identical, the value of the determinant tends to 0. These two are identical because C1 and C3 are identical. Since they are identical, the value of the determinant is equal to 0. Moving on to the next problem. Evaluate determinant of 1ABC, 1BCA, 1CAB. When you observe the first 5 problems, the RHS was equal to 0. In the 6th problem, we don't have RHS is equal to 0, which means we are not proving LHS is equal to RHS. We are just evaluating the determinant. So here, if I consider R2 tending to R2 minus R1 and R3 tending to R3 minus R1, I am considering which term? R2 and R3. So which row remains the same? The first row remains the same. What is the first row? 1A, B, C. What is R2? R2 minus R1. 1 minus 1. So this will be B minus A. Similarly, CA minus BC. Again, R3 minus R1. When you consider R3 minus R1, once again, what is 1 minus 1 equal to? 0. This is C minus A. AB minus BC. Implies 1ABC remains the same, 0B minus A remains the same. What is common here? C. If I take out C, what is left out? A minus B. So this is 1ABC, 1ABC, 0B minus A, 0B minus A. What is common here? C. If I take out C, what is left out? A minus B. Similarly, what is here? 0 C minus A, 0 C minus A. What is common here? B. If I take out B, what is left out? A minus C. B if I take out, A minus C. What do I have here? B minus A. But what do I have here? A minus B. When you observe R1, do we have any common terms in R1? No, we don't have any common terms. 1, A, B, C are all 3 different terms. When you observe R2, what is R2? 0, B minus A minus B. So, suppose I take out B minus A as common. What will be the sign of the third term? It will be minus C, because I am taking what as common? B minus A. So, take B minus A and C minus A as common factor in R2 and R3. Take B minus A and C minus A as common factor in R2 and R3. When we are speaking about R2 and R3, which two rows remains the same? R1 and R1 remains the same. So what is R1? What is R1? It is 1A, B, C. 0, what is taken as common factor? B minus A is taken as common factor. So it is 1. I have your B minus A, I have your A minus B. If I have taken B minus A as common, the term plus C becomes minus C. Similarly, 0, C minus A is also taken as common. What is left out? It is 1 again. Instead of plus B, since I have taken C minus A as common, the term plus B becomes minus B. So, when you expand the determinant, what is left out here? B minus A, C minus A. Next, expanding the determinant. Expanding the determinant, we get, B minus A, C minus A remains as it is. B minus A and C minus A remains as it is. Expand the determinant. What are the signs associated? Plus, minus and plus. So plus 1 into what are the terms left out? 1 minus C, 1 minus B, plus minus A into 0 into any terms, 0. Again plus BC into 0 into any terms will be 0 itself. So this can be written as B minus A, C minus A. When you expand 1 into minus B minus C, the formula is with minus sign. 1 into minus C will be minus C, minus into minus will be plus. What are we supposed to prove? A minus B, B minus C, sorry, what is left out now? Suppose I take minus as common here. What is left out? A minus B. Here if I take minus as common once again, what is left out? Here if I take minus as common once again, in the first term, if I take minus as common, B minus A becomes A minus B. Similarly, in the second term, if I take minus as common, minus B plus C will become B minus C, and the third term remains as it is, that is C minus A, in order to get the cyclic form A minus B, B minus C, C minus A. What is minus into minus? It is nothing but plus, which is equal to A minus B, B minus C into C minus A. This is the expanded form of determinant. With this, we have come to an end of today's session. In the next session, we shall solve few more problems based on properties of determinant. In case if you have any queries regarding today's sessions or the previous sessions, please feel free to upload your queries in the prescribed link. Thank you.